All right, in this session, we're going to go over the problems in the sample multiple choice problems on the website. We're going to do them all. Now, yes, multiple choice, you can narrow down the answer, and you might be wondering, why are we doing multiple choice when there's no multiple choice on this year's test? Because you can learn the concepts. You have to understand the concepts inside and out. So when you have your 5 choices, I want you guys not to like eliminate answers. I want you to just get the answer. And by the way, the answers are all at the end, yeah? Number 1, what is the limit as h approaches 0? Now, once you see that already, you know this is the definition of the derivative. You know already. Okay, here's the problem. This is the definition of the derivative. Your eyes should go here, right there. That is telling you that the function is cosine x, not cosine 3 pi over 2, cosine x. Because remember there's 3 definitions of the derivative. This one is f prime of 3 pi over 2. So what you have to do is you have to take the derivative and then plug in pi over 2. Well, the derivative of cosine is negative sine, and then you plug in 3 pi over 2. So you get negative 1, which is 1. Boom. Easy. Definition of the derivative, 2. So this one, they give you a graph, and they give you 5 points, A, B, C, D, E. Okay, it says, at which points are both the first derivative and the second derivative both negative? If the first derivative is negative, the function is decreasing. If the second derivative is negative, that means the graph is concave down. So where, oh, that's an ugly concave down. Where on this graph is the graph both decreasing and concave down? Well, that would be at B right there, right? You just have to understand what these things mean. Number 3, find the slope of the tangent line for the curve y cubed x plus, gosh, I can't even read that. I mean, how come I can't make this thing bigger? There it is. Y cubed x plus y squared x squared equals 6 at the point 2, 1. So look at the way it's written. You're going to be doing implicit differentiation to find y prime, and then just plug in 2 for x and 1 for y. So again, implicit differentiation, you take the derivative term by term. Now the first term is a product, so you got to use the product rule. Derivative of the first, 3 box squared times the derivative of box, which is y prime. Leave the second one alone. Leave the first one alone. Derivative of the second, 1. And again, remember, when you do implicit differentiation, the derivative of x is 1. The derivative of y is dy dx, or y prime. Plus, and then now look, we have another product over here, so you got to use the product rule again. Derivative of the first, 2y to the first times the derivative of y, which is y prime. Leave the second one alone. Plus, leave the first one alone, derivative of the second, which is x squared, which is 2x. Equals, and of course the derivative of 6 is 0. Okay, now to solve for dy dx, you have to put all the dy dx's on one side. So there's 2 terms with dy dx. Let's put them on the left. So you got 3y squared x y prime plus 2y x squared y prime. Everything else you move to the other side of the equation. Negative y cubed negative 2xy squared. So from the left side of the equation, factor out a y prime. Okay, I'm going to try to squeeze it in right here. Factor out the y prime, and you get 3y squared x plus 2yx squared. And that's equal to negative y cubed minus 2xy squared. And then all you have to do to solve for y prime is divide. So you're going to get negative y cubed minus 2xy squared all over 3y squared x plus 2yx squared. That's how you do implicit differentiation. Now all you have to do is plug in 2 for x and 1 for y. Can do. So negative 1 minus, and of course now you got to actually compute it because it's multiple choice, but you won't be doing this on the test. So 2 times 2 times 1, that's 4, all over 3 times 1 times 2, which is 6, plus 2 times 1 times 4, which is 8. So that's negative 5/14. I hope that's one of the answers. Yes. How many mistakes am I going to make today? Okay, now I'm going to tell you right now, number 4, we've never seen a problem like number 4. You know what? I'm not going to even go over it. Don't worry about it. Number 5. Okay, this problem we can do. F of x is equal to x to the 4th minus 2x cubed. Which of the following is true? Now, what are they talking about? They're talking about points of inflection, which comes from the second derivative, and extrema, which comes from the first derivative. So to answer this question, all you have to do is take the first and second derivatives and make number lines. You guys are good at that. Okay, derivative 4x cubed minus 6x squared. Factor out a 2x squared and you get 2x minus 3. Make a number line. 0 and 3/2 plus minus minus. How come it stays the same around 0? Because there's an even power on that. Or if you don't know, plug in numbers. So we got decreasing, decreasing, increasing. So there's one extrema only at 3/2. Probably can narrow it down, but I don't want you to narrow it down. Now take a second derivative, which is 12x squared minus 12x. Factor out the 12x and you got x minus 1. Make a number line. Wink. 0, 1. Plus, minus, plus. Concave up, concave down, concave up. So there's 2 points of inflection, right? One at 0 and one at 1 because the second derivative, f double prime changes signs, right? So there's one extrema and 2 points of inflection. Can we answer the question? 2 points of inflection and 1 extremum. Yeah, the answer is C. Number 6. F of x is equal to sine squared of 3 minus x. What is f prime of 0? All you have to do is take the derivative and plug in 0. Come on, this should be easy. Now remember, whenever you have a trig function to a power, we've been doing this the whole year, put the power like this so you can clearly see you're dealing with box squared. So how do I take the derivative of box squared? 2 box to the first times the derivative of the box. Okay, here's the box. Now, what do I see in the box? I see sine box. Okay, what is the derivative of sine box? Cosine box times the derivative of box, which is -1, right? The derivative of 3 minus x is -1. So you have box within box within box. That's how you have to deal with it. And for AB, we don't have to go any further. So all you have to do now is plug in 0. What happens when you plug in 0 for x? You get 2 times sine of 3 cosine of 3 times -1. I think you can pick out the answer now. Okay, number 7. Well, these problems are all over the place. Okay, I think we can fit it in here. Number 7. Solve the differential equation dy dx equals x cubed. See how this is so good practice for the free response. With y of 2 is equal to 3. Now I remember I made a mistake last time. This actually means the point 2 comma 3 now. Okay, now how do you solve differential equations? You put all the y's on the left, you put all the x's on the right. This is called separating the variables. Integrate both sides. 1/3 y cubed plus c equals 1/4 x to the 4th plus c, and we're going to mush those two constants together on the right. Now, compute the value of c now. Do not do it at a later step. Just do not. Okay, if I plug in 3 for y, you get 9. If I plug in 2 for x, you get 4 plus c. So c is equal to 5. So we know c is equal to 5 now. All you have to do to get the solution is solve for y. So first step, how do I get rid of this 1/3 here? Multiply both sides by 3. So you're going to get y cubed is equal to 3/4 x to the 4th plus 15. And then how do I get rid of the third power? You cube root both sides or raise both sides to the 1/3 power, whatever you want, same thing. So cube root of 3/4 x to the 4th plus 15. Pick up the answer. Bam, easy. Number 8. Oh, my voice is going. What's happening? What is the average rate of change? Okay, whenever you read the words average rate of change, this should be coming into your head. F of B minus F of A all over B minus A. That is the average rate of change on the interval from 0 to 3. So A is the 0, B is the 3. Okay, and then here's the function that they give you. So what you should have is you should have your cheat sheet next to you, and you should know exactly where the average rate of change formula is, so you can flip to that page very quickly. Okay, so f of b, so basically f of 3 minus f of 0 all over 3 minus 0 is your answer. Now, what happens when you plug in 3? You get 81 minus 15, 66 minus plug in 0, you get 0 all over 3. 66 over 3 is 22. There's your answer. Number 9, the position of a particle moving along a line. Oh, this is particle motion. We should be good at this. 2t cubed minus 24t squared plus 9t plus 7. For what values of t is the speed increasing? Okay, come on, we know exactly what to do. How do you tell when the speed is increasing or decreasing? You have to make number lines for the first and the second derivative, the velocity and the acceleration. Okay, so to compute the velocity, you take the derivative, 6t squared minus 48t plus 90. Factor out a 6. T squared minus 8t plus 15. Is that right? Yep, 15 is correct. Oh gosh, how come it's not writing? Factor it. That looks like a nice factoring. T and T, 3 and 5, minus and minus. So I'm going to put the number line up here because we want to stack them, right? Because it's easier to see when you stack them. Plus, minus, plus. Plug in numbers, whatever you have to do. Okay, acceleration, I think it's easier to look at this one. Take the derivative, 12t minus 48. Factor out a 12t minus 4. So your number line for acceleration is going to have 4 on it, and then positive, negative. So they want to know, when is the speed increasing? That means the velocity and acceleration have to have the same sign. So look at your number lines. Where do they have the same sign? Between 3 and 4, and then from 5 to infinity and beyond. And now you can pick out the answer. Mr. Park, these are multiple choice. Not too bad. That's because we know stuff. Number 10. See, this is the level of integral that you got to know on the AP exam. It's either on the list or you got to use U substitution. Now, what about this? Well, the way it's looking right now, Mr. Park, I don't know. Well, maybe if you multiply it out, they'll be on the list. So if you multiply this out, you get x to the 3/2 minus x to the 1/2. The reason why you want to write it like that, because remember, you want to make the power 1 bigger, right, to find the antiderivative, right? X root x is the same thing as x to the 1st times x to the 1/2. That's how I got x to the 3/2, if you were wondering, since we had algebra issues this year. So antiderivative, make the power 1 bigger, put the reciprocal in the front. Make the power 1 bigger, put the reciprocal in the front, put the plus c, and then pick out the answer. Mr. Park, I like these kinds of integrals. Number 11, what is the limit as x approaches infinity? Oh, this is not the definition of the derivative. Of this over 2 plus x minus 4x squared. Well, when you take the limit as x approaches infinity, they're basically asking you what is the horizontal asymptote. And how do you find horizontal asymptotes? If the degree of the top and the bottom are the same, you simply look at the coefficients, the leading coefficients. So what are the leading coefficients? 1 over -4. So that's why the answer is -1/4. Now, what happens if you couldn't remember that? Well, use L'Hopital's rule, right? Infinity over infinity, you can use L'Hopital's rule. Take the derivative of the top, which is 2x. Take the derivative of the bottom, which is 1 minus 8x. Yeah, but Mr. Park, it's still infinity over infinity, so then do L'Hopital's rule again. Take the derivative of the top, 2. Take the derivative of the bottom, -8. The answer is -1/4. See? L'Hopital's rule. It's good. Okay, number 12, they give you a graph. I'm disappointed. It's a parabola and a line. This is like, come on. Students should know how to graph this already. But I guess the AP people must know something. Okay, here's the region. Here's the graph of y equal 5x minus x squared, which is the parabola, and y equal 2x, which is the line. What is the area of the shaded region? Okay, so easy, right? Top minus bottom. So obviously the parabola is on the top and the line is on the bottom, multiplied by the width, because remember, you're actually making rectangles, yeah? And then you're gonna add it up from 0 to, how do we figure out where the point of intersection is? Well, you can either guess and check or set them equal to each other. What do you wanna do here? Maybe to make sure, why don't we equate them? So 2x is equal to 5x minus x squared. X squared minus 3x equals 0. Factor out an x minus 3. This is not too bad. X equals 0 or 3. So your points of intersection are 0 and 3, and that's how you get your limits. Now to compute this integral, you find the antiderivative. Make the power 1 bigger, put the reciprocal in the front. Make the power 1 bigger, put the reciprocal in the front. And then make the power 1 bigger, put the reciprocal in the front, which is 1, and you're going from 0 to 3. Plug in the top number. 45/2 minus 9 minus 9. Plug in the bottom number, they're all zeros. So basically, you got 45/2 minus 18, which is 45/2 minus 36/2, which is 9/2. There you go. Aren't you glad that you don't have to, right, compute numerical answers? You could have just left your answer like this on the fair response. In fact, you don't even have to compute 9. You can just go 3 squared, right? You don't even have to compute it. Number 13. Okay, if anybody gets this problem wrong, you owe me $20. I don't know how long we've been drilling on this. Oh, f of t dt. How do you take the derivative of a function that's an integral? You use the fundamental theorem of calculus part 1. You make sure the lower limit is a constant, which it is. So all you have to do is take this and plug it in here. So that would be f of x squared. And then the most important part, and also notice that this is one of the answers, right? But we're not going to fall for that. Then the most important part is you got to times it by the derivative of this. The derivative of x squared is 2x. That's your answer. See, that's why I told you the book, they almost always they make the top limit x, but that's not what's going to happen. It's not going to be x all the time. Number 14. Ooh, slope field. Okay, I'm not going to draw these. Which of the following is a slope field for the differential equations dy dx equals x over y? Okay, now this one you kind of have no choice but to what am I trying to say here? But to like eliminate answers, because what we normally do is you pick a point in a certain quadrant and then you try to eliminate answers, yeah? So what I like to do is I like to pick points in one from each quadrant. Okay, so what point do you want to pick in the first quadrant? Now, you probably want to stay away where they're like 1, 1, 2, 2, 3, 3. Pick something like 2, 1 or 1, 2 or 3, 2 or 2, 3 where the numbers are different. So in the first quadrant, what point do you want to pick? Okay, I heard 3, 2. So that means dy dx is equal to 3 halves. So that means at the point 3, 2, so your graph is going from -5 to 5. So it's something like this, yeah? 1, 2, 3. Here, let me just put them all in already. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 2, the slope is 3 halves, so it looks something like this. Steeper than 1, yeah? So can we eliminate some of the answers already? We can eliminate D. Okay, let's do this. A, B, C, D, E. So at the point 3, 2, we need so D is out. And then the rest, they look like it's possible. So D was the only one I could eliminate. Now let's pick a point in the second quadrant. How about -2, 3 perhaps? Then dy dx would be, what is that going to be? -2/3. So at the point -2, 3 up there, the slope has got to be -2/3. So negative going downhill, but less steep than 1. So can we eliminate any more? So we're at -2, 3. I think we can eliminate A. -2, 3. -2, 3 looks steeper than that. I can eliminate B, I think. What about C? -2, 3. That looks steeper. So it's got to be E then, right? -2, 3. That looks about right. There we go. Let's check that answer. I want to check it. 14E. There you go. Works every time. Okay, part B. Now you can use a calculator. So this is going to, you guys practice using your calculator. I'm going to take you to the point where you just punch it in on your calculator, okay? And then you can pick out the answer. You guys got to practice getting these answers, yeah? A particle travels on a number line and they give you the velocity. What is the total distance traveled from 0 to 2? Come on. Integral 0 to 2, absolute value of the velocity. So let's write it in now. 3e to the -3x over 2 sine of 2x dx. Punch that in on your calculator and pick out the answer. Just remember, total distance is the integral of the absolute value of the velocity. If you don't put the absolute value on, you get displacement. In fact, out of all the problems we've done so far, have you ever seen a displacement? In fact, the last 10 years, it's always been total distance traveled. I've never seen a displacement. Well, actually I have, but it's like 20 years ago. Number 16. Let S be the region enclosed by the graph of y equal 2x. Ooh, you guys are gonna have to draw pictures here. Oh, you get to use your calculator, that's weak. What is the volume of the solid when the S is revolved about the line y equal 3? So I'm gonna draw the graph here. Oh gosh, let's start that start already. So y equal 2x, it's a line, and y equal 2x squared, it's a parabola opening up, vertex at the origin, so it kind of looks like this. So here's the region right there. So you can see the points of intersection are at 0, and what is this right there? You can tell just by looking it's 1, right? Because if you plug in 1, both equations come out to 2. Okay, now it says revolve it about the line y equals 3. Okay, you know what? I'm going to redraw this picture because I'm going to go into the other thingy here. So the region looks like this. Yep. Y equals 3 is up here. Now, if you revolve, this is the line y equals 3 now. So you make the rectangle because we want it perpendicular to the axis of rotation. And what do you know? You have a washer. Now, for 2020, this is not the end of the test, but we're doing it anyway because you guys are going to college next year, right? All right, so what's the formula for the washer? Pi big R squared minus small r squared dx. Okay, so the big radius goes from the center to the outer edge. How do you find that? Top minus bottom. 3 minus 2x squared. The small radius goes from the center to the inner edge. How do you find that? Top minus bottom. 3 minus 2x. And you add up all of these washers from 0 to 1. And you only have to pick out the integral. You don't even need to compute it. Number 17. Okay, I'm going to draw this graph here because I think that's going to be important for the learning. So there's a vertical asymptote at x equal -1. And then there's a graph that comes up from infinity and it hits, there's a puka there at 2, and there's a point right below it. That puka is 2. And then it goes up there at 1. And then 2, 3, 4. And then it comes down to 2. And then over here, puka, point, curve. Okay, this is the graph of f. If the limit as x approaches b exists, Now remember, in order for a limit to exist, it has to approach the same point from the left and the right. It doesn't matter if the point is here or it's an open circle. As long as it approaches from the left and the right, then it exists. Then what could b be? And here are your choices. You got -1, 0, 1, 2, 3. So where of these 5 points does it approach the same point from the left and the right? Well, -1, no. Right? Oh, I forgot to even draw that. 0, no. 1, yes. Oh, wait a minute. I didn't even read the second part of the problem. The limit exists and f is not continuous. Gosh, I didn't even read. Is not continuous. I never read that second. Oh, thank you. I never read that second part of the problem. So it's not continuous. So the answer should be not continuous. It would be 0 then, right? Because look at 0. It's approaching the same point from the left and the right, but it's not continuous. And 1, it is continuous because there's actually a point there that I didn't draw in. And then at 2, the limit doesn't exist because it doesn't approach the same point from the left and the right. At 3, the limit exists, but it is continuous. So that's why the answer has to be 0. So that's why you have to know these terms. Number 18. I'm not sure why we needed a calculator for that. Okay, they give you a chart. I'm going to write out the values because we're going to actually need them. What we got? 1.1, 4.18, 1.2, whoop, 4.38, 1.3, 4.56, 1.4, 4.73. All right, let f be a function such that the second derivative is negative. That means the graph is always going to be concave down. So if you want to draw that picture in to help you out there. Selected values of f are shown in the table. Which of the following must be true about f prime of 1.2? Okay, that means what can you say about the slope when x is 1.2? Well, since we've been doing table problems for a while, how do you estimate the slope at f of 1.2? You use the point, well, since 1.2 is on the chart, you use the point that's closest, but there are two that are closest to it. So let's do both. Find the slope between these two. So you go y minus y over x minus x. But now we got to actually compute it. So you can punch it in on your calculator, but come on, we can do this, can't we? 0.2 over 0.1, which is 2. Okay? And then let's compute the slope between these 2 points, because those are the 2 points that are equally distant from 1.2. But actually, it doesn't matter in this problem because we just want an estimate of the slope. Yeah. So even though they weren't equally spaced from 1.2, we're probably going to do both of them anyway. So you go y minus y over x minus x. So what does that come out to? Let's see, 1.8. I'm not going to use a calculator over 0.1. That's 1.8. So let's just do this then. If the slope between these two is 2, and the slope between these 2 points here is 1.8, then shouldn't the actual slope, I'm going to put m, oh gosh, that's ugly. Then the actual slope should be between 1.8 and 2. Why would that be? The intermediate value theorem. Okay, number 19. 2 particles start at the origin and move along the x-axis from 0 to 10. Here are the position functions. x1 is equal to sine t. x2 is equal to e to the negative 2t minus 1. For how many values of t do the particles have the same velocity? Okay, well, let's compute the velocity of the first particle. The velocity of sine is cosine. What is the velocity of the second particle? The derivative of e to the box is e to the box times the derivative of box. And of course, the derivative of -1 is 0. So they want to know, when are the velocities equal? So here's the velocity of the first particle. When is that equal to the velocity of the second particle? Well, how do you solve any equation on your calculator? You make one side 0, cosine t, plus 2e to the negative 2t equals 0, and you graph this on your calculator. Except you got to punch it in with x's, yeah? Graph that on your calculator, and please graph it only from 0 to 10, okay? Graph it from 0 to 10, and all you have to do is count how many times it crosses the x-axis. Now, I don't know what that answer is. Just make sure your calculator's in radian mode. Number 20. Okay, they give you a graph. Well, so this is like a graph problem. We should be good at this. Okay, so they give you some points, 0, 2, 2, 0, -1, 0, and -2, -2. This is the graph of f. G of x is equal to the integral from 0 to x. See, we're not surprised by that. We've been seeing this a lot, okay? They're asking you, what is g of -1? So we're not going to use the fundamental theorem part 1. All we're going to do is plug in -1. So if you plug in -1 for x, you get this. But Mr. Park, the smaller number on the top. Well, that's why. Let's switch it. Put the smaller number on the bottom, but you got to negate the integral, right? Now, look at this integral. Oh, gosh. If f is this graph up here, what does the integral from -1 to 0 give you? The area between the graph and the x-axis from -1 to 0. So wouldn't that be this blue area right there, which is just the triangle? Okay, and what's the area of a triangle? 1/2 base times height. But don't forget that minus sign. So the answer should be -1. And now I also want you to notice that isn't one of the answers? That's why if you don't keep track of those minus signs, it's easy to get the problem wrong. 21. I hope we're nearing the end. My voice is getting tired. The graphs of 5 functions are shown below. Which function has a non-zero average value from -pi to pi? Now, what's the formula for average value again? 1 over b minus a integral from a to b of f of x dx. Okay, so they're asking which of the following is not 0. Now, of course, you can simplify that to 1 over 2 pi. Okay, so the only way that the average value can come out to 0 is this integral has to be 0. And they're saying there's only one where it's not 0. Like, for example, the first one, it is 0 because look at the graph. Zink, zink. It's an odd function, right? Odd functions are symmetric about the origin. So would you say that this area here is going to cancel out that area there? Because they're congruent, right? Except one is below and one is above. This one counts negative and this one counts positive. They cancel each other out. Same thing with B, they cancel. C, they cancel. D, they cancel. Well, it kind of looks like they cancel. But look at E. That's the only one that's not going to cancel out to 0 because look, you got this. So between the graph and the x-axis, look, the area that's above the x-axis is this, but the area that's below the x-axis is way more. So you're going to get a negative value for the integral because there's way more area below the x-axis than above. Hey, we only got 3 more problems. Why did I erase that page? I don't know. The base of a solid S is the semicircular region. Look at these guys telling you it's a semicircle. That's weak. But that's okay, we'll take it. And the x-axis. Okay, so this is the region right here. It says cross sections perpendicular to the x-axis are squares. We can do this. So if I put in the rectangle perpendicular to the x-axis, if I remove a slice, it's going to be a square. The base of the square right here is lying right on that rectangle. What is the length of the rectangle? Top minus bottom. So root 4 minus x squared minus 0. Now, if you know the side of a square, how do you find the area of it? You square it. That's the area of the square. But then it has a thickness to it, dx. And then you add up all of these slices from. Now, do you want to go -2 to 2? Or you want to go 0 to 2 and times it by 2 since you have symmetry? It doesn't really matter. Pick one and go with it. And I hope you guys know the limits were -2 to 2, right? Because that's when the y coordinate is 0, right? Okay, so what do we got? 2. Now we got to actually compute an integral. Now, you actually have a calculator here, but come on. We don't need a calculator for this one. Antiderivative, 4x minus 1/3 x cubed from 0 to 2. So 2 times, plug in the top number. 8 minus 8/3 minus plug in the bottom number, 0 minus 0. I will leave the computations to you. 23. Oil is leaking from a tanker. Okay, we already know where this is going already. At this rate, this is the rate at which oil is leaking from a tank in gallons per hour. Let me just make sure I copied that function correctly. Yes, I did. How much oil leaks out from 0 to 10? Come on. If you are given a rate, how do you figure out how much was done or how much leaked out? You do an integral from 0 to 10 of the rate e to the -0.2 t dt. Punch that in on your calculator. There's your answer. And 24 is our last problem. Yeah, baby. the derivative of f is sine of pi e to the x over 2. That's definitely a calculator problem. F of 0 is equal to 1. Compute f of 2. Come on, how many times have we seen this? What is this? Code red. See, they give you a function. You have to find out something about its antiderivative, right? The antiderivative of f prime is f. That's when you do code red. So what you do is you integrate f prime, whatever that is. See, because you can't find the antiderivative of it. Some of you think you can, but you can't. But you can do it on your calculator. Now, what limits do I put on this integral? 0 to 2. Why? Because one of them you know, and the other one you're trying to find. So according to the fundamental theorem of calculus part 2, what is this equal to? Well, if this is f prime, then isn't the antiderivative f? Plug in the top number, plug in the bottom number, and subtract. Okay? We already know that f of 0 is 1, and this you can punch into your calculator. So therefore, f of 2 is equal to this thing you punched in on your calculator. I have no idea what that is. You guys are going to do it. And then you have to add the 1 from this side, right? Easy money. So hopefully by this time, we know when we were supposed to use code red, the fundamental theorem of calculus part 2. All right, we are done. We'll see you later. Goodbye.